Good morning, everyone. My name is Landon, and my paper was on polypropylene fumarate, or PPF. So the name of my paper was Fabrication and Characteristic Analysis of Polypropylene Fumarate Scaffold using Microstereolithography Technology, and the scope of this was to develop a PPF scaffold using microstereolithography. Then they wanted to measure the ultimate strength and the elastic modulus of this scaffold, and then observe adhesion and growth of cells seated on the scaffold. One of the key addressed questions was, can this technology be used as a bone scaffold for tissue engineering? So the way that microstereolithography works is there's a UV light source which is projected into a UV curable resin on an XY and movable X, Y, and Z stage. And it just goes layer by layer. PPF is actually, it has too low of viscosity to use by itself in an application like this, so they had to dilute it with DEF, and then they used a UV curable. They only used 4% DMPA just to get it to be UV curable, but they tried 25% and 50% DEF just to see which one had the more favorable characteristics. They ended up going with the 50-50%. It was able to make a more accurate scaffold. The process conditions examined were the porous morphology of the scaffold, the compressive mechanical properties, and then cell adhesion. They used the universal testing machine to test the compressive qualities, and then they used a scanning electron microscope to be able to observe the cells after they were seated. For the mechanical properties, they made a solid cylinder, and then they also made a waffle type scaffold, and then they made two 3D scaffolds, one with 0.5 millimeter pitch and one with 0.8 millimeter pitch. The 3D scaffold with the 0.5 millimeter pitch showed a higher ultimate strength than the 0.8. Obviously, the waffle was higher than that, but they wanted to go with the 3D scaffold, so that was they were looking for a higher ultimate strength, so that's the one they ended up using. For the cell seating, I don't know why, but they used the waffle instead of the 3D scaffold. I'm not sure why they ended up doing that, but they took cells from it was from a septum, and they crushed those up. They took the fibroblasts from those and they cultured those, and they put those onto the waffle-shaped scaffold. And after a week, they observed that the cells had moved to the other side of the scaffold and on all the outside as well. So they considered it a success. And in conclusion, microstereolithography can easily control pore size, porosity, interconnectivity, and pore distribution. The fabricated scaffolds had similar properties to trabecular bone, and the cultured fibroblasts adhered to the scaffold. My personal critique of the paper it could use more data to back up the results. They kind of just said, okay, this is what we're going to do, and then they show a result and said this is what happened. They didn't exactly show all the data behind it or how many tests they did. And they did not show any testing or results of the cell adhesion to the 3D scaffold, only the waffle scaffold.